Hi everyone, let's do Leetcode 33 searching a rotated sorted array. We're given as input an integer array which is sorted in ascending order, and this input array could be rotated at a pivot. What this means is, let's say we had this input array and we want to rotate this array at pivot index 3, which is this one. What this means is that this part of the array is now going to become the beginning, and the beginning is now going to become the end. And this is the result we get. So we can see that we have two sorted portions, a left sorted portion and a right sorted portion. What we want to do is we want to search a given target and return its index. If this index doesn't exist, we want to return -1. It would be really easy if we just traverse through the input array and we looked for our target, but that's gonna take big O of n time, which is not what we want. The exercise is specifically asking for log n runtime, and we know that we can achieve that using binary search. So let's look at an example. So given this input array, we can see that this is rotated and it's sorted. We have a left sorted part and the right sorted part, and we are given target 0. So we want to be able to find this index 4 in log n time. Let's actually run through this example. So we know that in binary search we have 3 pointers, a left pointer, a mid pointer, and a right pointer. And we know that the left pointer has to be smaller or equal to the right pointer. So in this case, our mid pointer is going to start here, left is going to be here, and right at the end. What we want to do first is we want to determine where this mid pointer is. Is this mid pointer in the left sorted part, or is it in the right sorted part? And in order to determine that, we have this simple condition which we can use. So if nums at position m is greater or equal to nums of l, this mid pointer is going to be part of the left sorted part of this array. And the next thing we now want to do is we want to check, is our target in between left and middle? In this case, no, 0 is not in between here. 0 is actually smaller than left. So in this case, now we want to check on the right portion of the array, so we can get rid of all these elements and move our left pointer over here. So we now need to calculate the new mid pointer, which is going to be this one. Is mid equal to the target? No, it's not. Is mid part of the left sorted part of the array? Yes, it is, because this condition still holds. Is target in between here? Yes, it is. So what we want to do is we want to search in the left sorted part. So we're going to move our right pointer over here. And now our mid is going to be here as well. And our mid is now equal to target, so we can return the index. Let's now assume our mid pointer started here. We would do something very similar. In this case, this condition would not be true. So if this condition is not true, it means that we are in the right sorted part of the array. And what we want to do is want to first check, is target in between mid and right? In this case, no, it's not. It's smaller than right. We are just gonna eliminate the right part and move right. So this was just an example, but you can see how this condition helps us to find out which part of the sorted array we are in. And according to that, we can go to either the left or the right sorted part of the array. This is gonna get clearer once you see some code. It's actually quite simple. So the time complexity of what we have seen is big O of log n, and the memory complexity is big O of 1. We're just using pointers. Let's try some code now. So the first thing we need are 2 pointers, left and right. Left is gonna start at 0 and right is gonna start at the end of the input array. The next thing we want is a while loop, while left is smaller or equal to right. So we need this equal because the input array could just be a single element. So that's why we need the equals. We even saw this case in the example during the explanation. We want to calculate our midpoint, so left plus right minus L divided by 2. As explained, I prefer doing it this way so we avoid arithmetic overflow. Now we want to check if nums of m equal to our target. If it is, we return the index. Otherwise, we do some other operations. So we want to check, are we in left sorted part? And we can do this by using this if condition, which I showed you earlier. So if nums of m is greater or equal to nums of L, it means we are in the left sorted part. And now we want to check if target is actually greater or equal to nums of L and smaller than nums of m. So this basically means if target is between left and middle pointer, we want to search towards the left of this sorted part. So we're gonna move our right pointer to be equal to mid minus 1. Else we're gonna go to the other side, so left equal to m plus 1. And if this is not true, we are in the right sorted part and we want to do something similar. So if target is in between nums of m and nums of r, we wanna stay there and we want to actually just increase left pointer to be equal to mid plus 1. Otherwise, we're just gonna decrease the right pointer, so we're gonna search towards the left. And if we get out of this while loop and we have not found our target, it means that it doesn't exist, so we can simply return minus 1. As you can see, it does work. If you found this video useful, please like and subscribe. Also check out my YouTube channel, you're gonna find many more Leetcode questions and other videos that I hope you're gonna find useful to prepare for your technical interviews. Thank you.